is Alexis Mayu, and I did my presentation on Leonhard Euler. So a little bit of background about his life is that he was a Swiss mathematician who lived from 1707 to 1783. He did a lot of important work in number theory, algebra, geometry, calculus, probability, trigonometry. He was born in Basel, Switzerland, and he was the oldest of 6 children. He attended the University of Basel, where he was studying mathematics. Originally, though, he was going to follow in his father's footsteps and study theology. His father was a pastor, and it wasn't until his father's friend Johann Bernoulli, who was also a mathematician, convinced Euler's father to allow him to study mathematics instead of theology. He studied at the university, and in 1727, he moved to St. Petersburg to work and study at that academy. He became a professor of physics in 1730, and then in 1733, he became a professor of mathematics. So a little bit prior to him being a professor, he was also working as a medic in the Navy, and then he was also a philosopher. He published a lot of work. He wrote and published a lot of books, a lot of memoirs, and submitted them to the academy where he was working. He was able to take calculus to a higher degree and was able to develop theories of trigonometry and logarithmic functions. So Euler's formula for polyhedra. In 1758, Euler stated the formula of Euler's formula for polyhedra, where F is equal to the amount of faces in which the shape has, the E stands for the amount of edges the shape has, and then the V is equal to the amount of vertices. And this equation would be noted as F minus E plus V equals 2. So, for example, when you're looking at a cube, we know that a cube has 6 faces, 12 edges, and 8 vertices. So when you do 6 minus 12 plus 8, you get the number 2. And this works for all of the polyhedrons. When you look at the tetrahedron, you have 4 faces, 6 edges, 4 vertices. 4 minus 6 plus 4 equals 2. So on and so forth. Okay, so then at the age of 27, Euler was able to contribute to the world the Basel problem. He was able to find that the sum equaled pi squared over 6. The purpose of the Basel problem is to ask for a precise summation of the reciprocal of the squares and its natural numbers. And he just found a simpler equation in which that could be done. So his contributions to math notations was something that I found interesting. Some of the contributions, just 2 of them, is he was able to contribute the actual function of f of x. He was the one that put that in place, as well as assigning the Greek letter pi to equal what it means of 3.14. Euler's illness. So as Euler progressed in his life, he ended up becoming ill. He had a lot of aneurysms, which then led to him having diplopia in his right eye, which led to atrophy of his right optic nerve, and then that caused him to become blind after his left cardiac surgery. And later on, he passed away in 1783 due to a brain hemorrhage. Something I found very interesting about this was that while he was partially blind, he was still contributing all of his research. It was noted that he had a big chalkboard on his desk, and he would write in big letters on his desk to allow him to see somewhat of what he was writing, which helped him later on publish half of his research, which has been beneficial for us now when we look at any type of math subjects, geometry, trigonometry, calculus, statistics, or if you're looking in the medical field or architecture or mechanics, engineering as well, you name it, we still use it to this day because of all of the formulas and contributions he made to mathematics and science and physics, and I also believe music as well.